Okay, this is Unit 3. This is video number 6. We are now going to talk about valence electrons. Valence electrons are really just regular electrons. There's nothing special about them physically. One electron is going to be the same as any other electron. Valence electrons are special because of their location within the atom. So physically, nothing makes an electron special, but where it is at is what makes it special. Valence electrons are in the outermost energy level of an atom. They're on the outside. They are responsible for the chemical behavior of an atom. Since they are on the outer layer, or in the outer layer, any electrons that end up being lost or gained will be from the valence electrons. To figure out the number of valence electrons in an atom, we're going to look at the group number. Looking at the group number, group 1 has 1 valence electron. Group 2 has 2 valence electrons. These ones are really easy to remember. Group 1 has 1, group 2 has 2. We're going to skip the transition metals. So we are skipping groups 3 through 12, that big block in the middle full of metals. Then we're going to pick back up for groups 13 through 18. So what we have to do is start with the group number. To find the number of valence electrons, we subtract 10. So group 13 would have 3 valence electrons. 13 minus 10 is 3. Group 16 would have 6 valence electrons. We've been using the same 4 elements for all the examples in this unit. We're going to continue on with that one. So neon is our first element. First, you need to look at the periodic table and find its group number. So I look up, its group number is 18. Groups 13 through 18 require a quick calculation. 18 minus 10, which would tell me the number of valence electrons for neon is 8. Oxygen, looking at my periodic table, is in group 16. So to find its valence electrons, I do 16 minus 10, and that tells me oxygen has 6 valence electrons. Magnesium is in group 2. There is no calculation needed because everything in group 2 has 2 valence electrons. Silicon is in group number 14. 14 minus 10 tells us that we have 4 valence electrons for silicon. And this works for any of what we would call the main group elements. And the main group elements would be groups 1 through 2 and 13 through 18. On a related note, on the next page, we're looking at something called the electron dot structure. An electron dot structure represents an atom. It's another model. The electron dot structure only shows valence electrons. They're the ones on the outside. They're the ones responsible for the chemical behavior of the element. So these are the only ones that we really need to know about the chemical behavior. So we can get an idea of the chemical properties without the long electron configuration. Electron dot structures are especially useful when we start representing the chemical bonds between two or more elements. So as we'll see in chapters later on, atoms will gain electrons, they might lose electrons, or they might share electrons, all with the goal of becoming more stable. When an electron doesn't have enough electrons, it's unstable. When it has too many electrons, it's unstable. They want to get to a point where they are as stable as they can be. So here's how to do the electron dot structure. For the element neon, first off, we have to know how many valence electrons that it has so that we can represent it in the electron dot structure. So our quick calculation, it's in group 18. Subtracting 10 tells us that it has 8 valence electrons. And here's how we draw its electron dot structure. I didn't write a procedure for it. That would be really a waste of space. Start with the atomic symbol. In this case, it's Ne. We are going to use dots that represent electrons, and here's how it's going to work. So we draw 1, 2, 3, 4. See how they're on the 4 sides. And then 5, 6, 7, 8. So we have electrons on 4 sides, and they are grouped into pairs of 2. They're grouped into pairs of 2 because when we did the orbital diagram, remember they were grouped into orbitals, and they were in terms of pairs. And so we're keeping them in terms of pairs in this electron dot structure. Oxygen, finding it on the periodic table, it's group 16. For valence electrons, we subtract 10. That tells us 6. If you look at your orbital diagram for oxygen, you'll see what the electron dot structure should look like. So let's fill the dots in. Here's 1, 2, 3, 4. Notice that I am going around and putting 1 on each side before I put doubles. 5 and 6. If you're looking at its electron dot structure, you will see 2s2. There's 2 in that box. And then in the 2p, there are 2 in the first box, 1 in the second box, 1 in the third box. And this, to some degree, tells us that same information. Magnesium is in group 2. Group 2 elements have 2 electrons. There's no subtracting 10 here, just 2. So we start with our atomic symbol. And here's 1 electron, here's 2 electrons, and they're separated. In our orbital diagram, they're in the same box. Here they're separated. And that's just because we start and we go around the atoms in a clockwise manner. Silicone is in group 14. To find the valence electrons, we subtract 10. There's 4 valence electrons. So silicone, we can start drawing our dots. Here's 1, here's 2, here's 3, and here's 4. 1 on each side. And that is the end of Unit 3.